everyone. Welcome to the Eureka Math Workshop. The title of this workshop is called Understanding the Major Work of the 3 to 5 Grade Band. In particular, today we're going to talk about multiplication. But even more specific than that, we're going to be discussing the progression from concrete to pictorial. And this progression is present throughout the entire Eureka Math grade level bands from K to 12. This particular progression from concrete to pictorial is especially important in developing that deep conceptual understanding that we're pushing for with each math concept with Eureka Math. So starting with the concrete, I want to demonstrate this progression with multiplication. And so for multiplication, and since we're discussing place value, we're going to use something called place value disc. And that's those little colorful discs that everyone has at their table for their use. So as I'm doing this problem, we're going to do this together. We're going to use place value disc, set this problem up, and then solve. So when we're using place value disc, we don't use a labeled place value chart. That's just because each unit has its own individual label. When it comes to the pictorial, and you'll see with the chip model in just a second after we finish up with this particular problem, the pictorial does use a labeled place value chart. That's because each chip or each unit is drawn as simply as a dot. So the units between the ones, tens, and the hundreds place look the same essentially. It's a dot, but the difference is what place it's in. The place determines its value. So those place heading labels are going to be especially important. But since we're starting with the concrete, we're just going to use place value disc to make this number. This is going to be our group size. And then so 3 is going to represent our number of groups. So each group is going to be a size of 23. So let's start with 23 in unit form. What is 23 in unit form? Yep, 2 10s and 3 1s. So if everyone could just use their place value disc and put 2 10s and 3 1s on here like that. And so that's our one group of 23. And then so we're going to make 2 more groups. So just go ahead and use your other place value disc to make 2 more groups of 2 10s and 3 1s, or 23. And that unit form, same 23 as 2 10s and 3 1s, it's really important to emphasize that, especially as we're building numbers. Because when we're talking about place value disc, when we're saying 2 10s and 3 1s, we can literally pick up and place 2 10s and literally pick up and place 3 1s onto our place value chart or onto our whiteboard or wherever our workspace is. So uniform is especially handy in that. And it also just deepens their understanding. Numbers in standard form are super abstract. So being able to identify which digit is in which place and how many units of that particular place we have, it does a lot for a student's conceptual understanding. But here we are. Does everyone have this? Yes? Okay, anyone need more time? Great. Here we go. We have 3 groups of 23 or 3 groups of 2 10s and 3 1s. We can start with the ones place, right? I want to find the total of our ones and our ones place. Notice how this is set up. Notice how these units here are set up. What does this look like? Yes, it looks like an array, right? So this is 3rd grade here. This is taking it back even to 2nd grade, where we are learning about arrays and learning about equal groups. So even within each place, we're able to make 2 separate arrays and make equal groups within each place. Within these equal groups, three equal groups of 23, we're able to make 2 different groups of 2 different equal groups. So looking at the ones place, what's the total of the ones place? Yes, we have 3 groups of 3 1s, which gives us 9 1s. So go ahead and record that total under your ones place. And then we can move on to the tens place. Here in the tens place, we have 3 groups of 2 10s. How many 10s is that? Right, that is 6 10s. So 3 groups of 2 10s equals 6 10s. So now we can get a total. We can add both of our places together to get a total for how much 3 times 23 is. So 6 10s plus 9 1s is how much? 69. And then also side by side with the place value disk or even the pictorial, what we want to do is also set up the algorithm. And so we just want to set up vertical form on the side here so that students are able to align the concrete manipulation of the place value disk with the abstract the abstract procedures that are happening with the algorithm. So in the ones place, we multiply 3 groups of 3 ones, and we got 9 ones. And then for our total of our tens, we got 3 groups times 2 tens in each group, and that's 6 tens, which is 60. And then when we add our ones and our tens together, what do we get? What total do we get? 69, right? The same total as our product. So this is the side by side with the concrete and the algorithm. So now let's progress. Just like the curriculum progressed, we're going to progress now, and now we're going to move on to the pictorial. And so with the pictorial, we're going to use the participant handout. So if you all look at your materials, there is a participant handout. There's also a screen protector because we're just going to insert that particular handout into the screen protector. And we're going to use this as a whiteboard to draw in our chips on this place value chart that's here. So let me just zoom in here so we can all get a good look. Focus in on that. Okay, so we are going to be solving 4 times 34. So something that was interesting about 3 times 23, that problem that we just did, is that there was no regrouping. We did not have to compose 10 smaller units into a larger unit. But with this, let's look at what that would look like if we did have to do that, if that was necessary to compose with 4 times 34. So similar to how we use the place value disk, we're going to make 4 groups of 34. One of these factors is the size. The other factor is the number of groups. There's 4 groups of 34. So 34 in uniform is, 3 tens and 4 ones. So starting with one group, 3 tens, 1, 2, 3, 4 ones. And then we need 3 more groups. So go ahead and add that in as I add them in myself. All right. So we have that set up. We have our 4 groups, of 34. Now let's get some totals for each place. Starting with the ones place, of course. Let's get a total for the ones place. In our ones place, we have 4 groups of 4. Everybody take a second to think about 4 times 4. How many ones is that? 16 ones, yes. All right, so we have a total for our ones place. What about our tens place? What's our total for our tens place? How many tens is this? Well, it's 4 groups of 3 tens. That's 4 times 3 tens, which is 12 tens. So here's a question, and this is a question that you would ask your students. Are we able to regroup? Is there regrouping that needs to happen? You can also be very flexible with the vocabulary because there's other words for regrouping, right? Are there units that we can bundle? Are there units that we can compose here? Because at this point, students should definitely know that it takes 10 smaller units to compose 1 larger unit. So hopefully they're able to look into the ones place and notice that they're able to compose a 10. And that just simply looks like circling 10 of these little dots here. So 8, 9, 10. And then now with these 10 ones, I know that that would equal 110. And then hopefully as well, they're able to recognize that you are able to compose in the tens place as well. And 10 tens equals 100. And so that's literally just circling those 10 tens and moving one over, adding a new unit to the hundreds place. So then now we can get the total of the entire place value chart. And which would give us our product for 4 times 34. What do we have? How many hundreds do we have? 100, right? And then how many tens do we have left that are unbundled, uncircled? 3 tens. And then how many of 2 tens plus that new 10, right? That new 10 that we were able to bundle from the ones place. And then how many ones are left? 6 ones. So that gives us a product of 136. What does that look like in the abstract form with the algorithm? Let's see. Go ahead and set up the algorithm on the side of your place value chart too, so we can just kind of make some connections between the pictorial and the algorithm. So here, with the algorithm, we multiply, and similar to our ones place, we multiply 4 times 4. 4 ones times 4 groups, which was 16. And then we went on to multiply our tens, and we got 12 tens. 12 tens in standard form, somebody? Yes, 120. And then just like what we did in our pictorial version, we're adding and regrouping in each place, so that we end up with 6 ones, and then we add here with 3 tens, and then we end up with 100 for a total product of 136. Just take a moment to just look and talk with your partners about the similarities you notice between the pictorial version and the abstract version.